Hello everyone, thank you for joining us for this intermediate Tableau workshop. The workshop materials are available from the DMC homepage under the section Asking for Help, DMC Guides. From the DMC Guides homepage, scroll down to the section of Research. You will see the workshop handout, data files, and the links to the published visits. This workshop has two parts. The first part is a brief presentation. We will recap what we have covered in the introduction workshop, and we'll talk about the objectives for this workshop. We will spend most of our workshop time on the second part, that is to use hands-on activities to learn more Tableau features. In the introduction workshop, we have covered data visualization workflow with Tableau. First, you need to connect to your data, and then you can analyze it, and then you can save your work. When you connect to your data with Tableau Desktop, the full version, you're able to connect to a wide array of data sources, such as static files like Excel, CSV file, traditional relational database, or cube database, or database in the cloud, or just public data on the web. After data is connected, you can start your analysis process. You can create basic views like bar chart, line chart, or text table with worksheet. After you have a few worksheets created, you can put them together to build interactive dashboards. Dashboard allows you to view, monitor, and compare more data at one place. Interactive dashboard also allows you to see and understand your data better. And last, you want to save and share your work. You can save your work together with the underlying data in the packaged workbook. And this packaged workbook can be opened with any Tableau desktop or Tableau reader. You can also save your work to Tableau server or Tableau online. We have used Tableau Public for our workshops. Tableau Public is free. It has some limitations. In terms of connection, you're limited to connect to static files. You are not able to connect to databases. In terms of analysis, there's no difference between the full version and the free public version. When it comes to save your work for Tableau Public, you're limited to save your work to Tableau Public server. You're not able to save any work locally. If you work with confidential data or data that is security sensitive, you may want to remove it before you save it to the Tableau Public server. Two very important concepts, dimensions and measures, I want you to understand from the introduction workshop. After data is connected, each column header is viewed as a field. Each field is assigned a data row, whether it's a dimension or measure. They are separated by a thin green line in the data pane. So dimensions are fields that hold qualitative categorical information. They cannot be aggregated. For instance, average or sum will not work. In contrast, measures are fields that hold quantitative and numerical data. They can be aggregated. For example, sum or average, they will work. Further, when measures come to the view, they will be automatically aggregated. In this case, number of charges is a measure. So when it comes to the view, the sum, this aggregation, the default aggregation method is automatically applied. And when a measure is dragged to the view area, axis generated. So you will see this axis for number of charges. Dimensions, they are used to split a measure. In this case, time charge is a dimension. It is used to split number of charges. So the total number of charges that one number has been splitted to 3 numbers based on the values in time charge. So one number becomes 3 per year. When dimensions are added to columns or rows, they become headers. Dimensions and measures, they work together to build your view, your data visualizations. In brief, measures are automatically aggregated when they come to the view. Dimensions are used to split measures. They define the level of aggregation or they define the level of details. For any data analysis project, data preparation is a significant part of the project. In this workshop, we will see how to use Tableau's built-in features to prepare data. That's the data preparation part. We will also learn more Tableau features to visualize data. That's the data visualization part. Specifically, for data preparation part, we will cover how to use Tableau's data interpreter to clean data and how to use its pivot function to reformat data and how to use 2 basic methods, join and union, to combine data. For the data visualization part, we will take a look at this finished visits. We will compare 2 measures in one chart to create a scatter plot and to view more measures in one chart, to view more measures in a text table, to create calculated field to better see and understand our data, and how to use quick table calculations, and how to map geographic data, how to create parameter and use parameter in the filter or calculated field, how to apply analytic objects such as reference line to your worksheet, and we will put together a dashboard like this, and also we'll see how to use a parameter to build interactive dashboard. Let's get started. Navigate to where you have your data files saved. Click on Data Prep Flight. This Excel file has 2 sheets. One is resolved incidents and the other is ideal. Ideally, your data should be formatted like the ideal sheet. The first row only includes column headers. The sheet does not contain comments or notes in the beginning or anywhere on the sheet. Each column contains the same type of data and each row is one data entry. In contrast, in the resolved incidents sheet, we see there are a few problems here. First, the first row is not column headers. It contains notes in the beginning and at the end of the sheet. In addition, we see each month is a column. This cross-tab view is really good for a human being to read at a glance, but it's really hard for Tableau to aggregate data across months. We will see how we can clean up data and reformat data to make this sheet look like the ideal sheet. Open Tableau Public. On the Data Connection interface, click on Microsoft Excel. Navigate to where your data files have been saved. Click on Data Prep Flights. Click Open. Drag Resolved Incidents to the canvas area. You can click to close Table Details. You will see because there are comments in the beginning of the worksheet, the column headers have not been interpreted properly. So on the left-hand side of the data source interface, click to check Use Data Interpreter. Immediately, you will see the notes have been removed and the correct column headers have been viewed as fields. Data has been interpreted properly. If you wonder what happened after you click Use Data Interpreter, click Review the Results. This will open an Excel file, and you will see key for the data interpreter on the first sheet. For the resolved incidents, and you will see this row has been interpreted as column headers, and the green color area has been interpreted as data values. So data has been cleaned up. Now click on sheet 1 and drag employee to rows. If we want to know the number of incidents resolved per employee across 12 months, we will see that's January and that's February. So it's not intuitive to see the total number of incidents resolved per employee across 12 months because all values are stored under 12 different months, 12 different measure names. In order to make this kind of aggregation across 12 months easier, we will reformat data. Back to Data Source interface, click to select January 2015 and hold down Shift and select December 2015. And from the drop-down menu, choose Pivot. This pivot function essentially merged the original 12 columns of information into 2 new columns. One is pivot field names and the other is pivot field values. So pivot field names are actually our dates. So we can rename it as date, and pivot field values are kind of like number of resolved incidents. So now click on sheet 1. You will see all values have been stored under one measure field name. That is the number of resolved incidents. When I drag it to column, it aggregates all the values across employees and across all the 12 months. So if I drag employee to column, that will split the number into 26 values, 26 marks based on the number of employees. So each mark, each number is the sum, like the total number of resolved incidents for each employee across 12 months. So after data is reformatted, we will see how easy it is to aggregate value across months. So the data structure can be very important for you to do different kind of analysis. We also noticed each value for employee has 2 parts, a letter part and a number part. The letter part is employee location and the number part is employee ID. So if we want to see the number of resolved incidents for employee location, we can split this field into 2 fields, and then we can easily see the total number of resolved incidents for each location. So we will do that through the drop-down menu of employee, transform. We can do automatic split or we can do custom split. For custom split, we can choose a defined separator. We'll go back and we'll do the automatic split. Automatic split will use the default recognized separator. Over here is a hyphen and split one field into 2 fields. So the first part will be employee location, and the second part will be employee ID. If we want to see what values are contained in employee location and employee ID, I can click to create a new worksheet and drag it to the new worksheet you created, and you will see employee location only contains the letter part of the employee. And if I drag employee ID and to the worksheet area, you will see it contains the number, the identification part of employee. So that's what we want. And if we want to see like number of incidents result per employee location, I can put it over there. And then you can swap rows and column, and you will see the number of incidents result per employee location very conveniently. On the handout on page 6, you will see the do-it-yourself activity. Create a worksheet with the following requirements. When you work on a data analysis project, it is inevitable sometimes you have to work with data from different data sources. With Tableau, there are 4 ways to combine data from different data sources. They are relationships, joins, unions, and blends. In this workshop, we are going to cover joins and unions. In brief, join is a method for combining tables related by common fields. After join, the table will grow wider. You will add more columns to an existing table. Union is a method for appending values, rows to tables. The 2 tables should have the same column headers, should have the same columns. After union, your table grows taller. Let's take a look at the 2 files we're going to join. One is products 2016 and the other is sales 2016. Open the file 6 2016. We can see this sheet contains all the sales information and product ID, but it doesn't contain any product information. When we open Products 2016, we can see the sheet contains all the product information, but not sale information. Also, it includes product ID. So the common field for these 2 files are product ID. If we want to see a certain product's sale information, we have to combine the data. Open Tableau Public. On the data connection interface, click on Microsoft Excel. Navigate to where your data files are saved. Click on Sales 2016 and click Open. On the data connection interface, on the left-hand side, click on Add. Since Products 2016 is a CSV file, so it's a text file. Click on Text File. Select Products 2016. Click Open. Both files have been connected. When Sales 2016 is connected, the table is automatically put onto the canvas. The canvas has 2 layers, the logical layer and the physical layer. By default, it is on the logical layer. The logical layer is used to create data models and to use relationship to combine data. Join has to be done at the physical layer. So double click on Sales, and this goes to the physical layer. If you want to go back to the logical layer, you can close it, and this goes back to the logical layer. So double click on Sales, and this is at the physical layer. Click on Products 2016 and drag Products 2016 table to the canvas area and just drop it. And you will see a join operation has been applied to these 2 files. If you click on the join icon, you will see there are 4 join types: inner, left, right, and full outer. Inner join will preserve only the rows that have the same key field. Over here, that's the same product ID. Left join will keep all the rows from the left table. Over here is the sales table, so it will keep all the rows from the sales table. And for each matching product ID, the information, the values from the right table, products 2016, will be added to the left table. So if we select left join, below the canvas area, you will see all the rows in the sales table has been preserved. And you will see 51290 rows. If I bring up the sales Excel sheet, and you will see the total number of rows is 51291. That includes the column headers row. So the number of data rows is 51290. So we can tell for left join, all the rows from the sales table has been preserved. You will see the blue color above the sales table and orange color above the products table. So the color tells you the column is from which data source. Similarly, the right join will keep all the information, all the rows from the right table, and for each matching product ID, and the values from the left table will be added to the right table. The full outer will keep all the rows from the left and right, and for each matching product ID, each matching key field, the columns will be joined. So your table will grow wider. For this practice, we will keep left join. So after the data has been joined, click on Sheet 1. By default, you will see the fields are organized by data sources. If you right-click over inside the data pane, you can choose Group by Folder. The fields will be blended nicely together, and you will only see dimensions above the thin green line and measures below the thin green line. So the data has been joined together. Open your handout, go to page 9. I would like you to build a view with the following requirements to test the joined data source. Open Tableau Public. Click on Microsoft Excel. Click on DMC Charges Data, 3 sheets, and click Open. While the data is connected, let's take a look at the Excel file we are going to work with, the 3 sheets Excel file that we are going to union. So union is when you work on a data analysis project, you have more data coming in. The new data has the same number of fields as the old data table, and each field has the same name and data type. For the DMC equipment circulation data, like first we have data from 2014 to 2016, then we have data for 2017, and then we have data for 2018 and 2019. And you can tell from each sheet, they have the same data structure, the same number of fields, and the same column name, and the same data type for each column. There are 2 ways to union data. The first way is you just drag one sheet to the column area. And for union, the sheets has to come from the same data connection. And the canvas area has 2 layers. Remember, the default view is logical layer. Union has to be done at the physical layer. So double click on this logical table to go to the physical layer on the physical table. And then you drag the second sheet instead of drag and drop. So when you drag and drop, the default operation is join. So you drag it close to the existing sheet, and you will see the orange box, drag table to union, and you release your mouse button to union. And you do the same thing for the third table. Drag close enough to the existing two tables and release your mouse button to union data. If you just drag and drop to the canvas area, the default operation is join, not union. So now all the three sheets have been union together. You can close the physical layer and go back to the logical layer. You can also remove the union, and you can double click new union, and then you can click to select all the three sheets and drag it to this area. Although you got this unexpected error message, but actually union has been applied. I'm not sure why Tableau always gives this error message. So click OK. Once again, we need to make sure default data tab is correct. For time chart, it should be date and time. And everything else looks good. So I'm going to go to sheet 1 to test the union data. So if I drag number of charges to the view area and drag time charge to rows, we will see the data is ranging from 2014 to 2019. When I expand it, I will see the data for 2019 is not complete. It only includes the first 3 quarters. So I'm going to click and exclude it. So I'm going to focus on the data for this 5 years, because we have complete data for this 5 years. And if I click on show me, I can select line chart, and you will see over years this pattern of this equipment checkout data. I can also click on year, and you will see the number of equipment checkout gradually going up. So the 3 sheets has been union together. They work as a single data source. So this is about data preparation. We have seen how to use data interpreter to clean data, how to use pivot function and like split function to reformat data. We have also seen how to combine data with join and union. Remember, the data canvas area in the data source interface has 2 layers, the logical layer and physical layer. And by default, the view is logical layer. So in order to join and union, you need to double click on the logical table to go to the physical layer to do the operation. Once data is joined or unioned, they work seamlessly like one data source. So you can freely do your data analysis. Next, we will move on to the data visualization part. We're going to use sample superstore data. This data comes with Tableau desktop's installation. It's prepared by Tableau. I just tweak it a little bit. So let me open this Excel file, and let's take a look at the data we're going to work with. So this Excel file has 3 sheets. We're going to use orders sheet. If I select the first column, we will see it has 9995 rows. The first row is column headers, so that means we have 9994 rows of data. Each row contains a product in an order, including order date, customer information, product information, sales, profit, this kind of information. So let's open Tableau Public and connect to this data. drag orders to the canvas area. And I will close on Table Details pane. From the summary, we can tell there are 22 fields and 9994 rows of data. And we know from the Excel file that's correct. There are 9994 rows of data. And when we look through column headers, the fields and the data tab, everything looks right. So I'll just click on Sheet 1 to start our data analysis. It is important for any analysis to compare measures. What if I want to compare profit to sales? With Tableau, we can use this dual axis chart. So if I drag profit to rows and I drag sales next to profit rows and I drag order date to column. So I have two lines on two charts. If I right click over the sales axis, I can choose dual axis and I can right click over this axis and choose synchronize axis. So now I have two measures on one chart in one view, two measures, one dimension in one view. I can edit the color legend. If I want to swap the color, I can choose profit like orange and sales like blue color. So this is the dual axis chart. If I right click on this and duplicate, and if I click on profit and I change its mark type to say bar chart instead of line chart, then I have this what they called combo chart. Scatter plot is a useful chart to visualize relationships between two measures. One advantage of using scatter plot is that you can plot a lot of data at once and be able to spot trend, clusters, and outliers. Let's create a scatter plot. Create a new worksheet. And we want to see the relationship between profit and sales. Drag sales to columns and profit to rows. Now we have one mark showing the sum of sales and profit values across every row in the data source. Remember, when we drag measures to columns or rows, they are automatically aggregated, and the default aggregation method applied over here is sum. To deaggregate measures, there are two ways. The first way is go to Analysis and uncheck Aggregate Measures. And immediately from one mark, we have now 9994 marks. So each mark is a row of data in the data source. Notice, like if you select a mark, you cannot exclude or keep only because you cannot create a data source filter this way. Let's see what kind of insights we can spot for this scatter plot. Drag region to color. Not much discernible, so we'll just remove region. Let's drag category to color. It looks like furniture does not profit much. So click on Analytics tab, and we will see if we use trend line, and the trend line will tell us the same instinct. So drag trend line and drop it to linear. From the trend line, we can tell it seems furniture does not profit very much. You can edit the color legend to the way you like it. So I'll just keep furniture like this orange color. Also notice when you mouse over a trend line from the tooltip, it shows the equation used to calculate the trend line. And R squared, and p-value. Those are statistical measures that help tell how well your data fits the data model. We can rename this as scatter plot 1 and create a new worksheet. Drag sales to column, profit to row. There's another way to deaggregate measures. Say if we drag customer name to details, and immediately we have 793 marks. Sales and profit are aggregated based on the dimension customer name. Also notice if you spot any outliers, you can select it and you can keep only or exclude to add a dimension filter to the filters shelf. You can add a dimension filter this way at this level. I'll just remove it. We have seen how to compare two measures in one view in the same chart. If we want to compare multiple measures in one view or in the same chart, we will need to use measure names and measure values. We notice measure names, measure values, and orders, longitude, latitude are italic. That means these fields are not from your original data source. They are automatically generated by Tableau to help visualize your data. Specifically, measure names and measure values are generated to help you to view multiple measures in one view. So create a new worksheet, drag order date to columns, and we will choose a continuous month, and drag measure values to rows. Measure names, as its name indicates, it contains all the names of your measures in your data source. Measure values contain all the values of your measures in your data source. Now we have this one line chart. Drag measure names to filters. We want to remove count of orders, discount, and quantity. We will leave this profit, sales, and discount amount because they have the same measure unit, dollar. Count of orders, discount, quantity, they have different measure unit. It doesn't make sense to add them up, to put them all together since they don't have the same measure unit. Click OK, and we will see only values for those three measure names have been left. And once again, drag measure names to color. Now we have separated that one line into 3 lines, and we have this multiple measures in one view in the same chart. We can rename this as multiple measures. We can also create a text table with multiple measures. Create a new worksheet. We can double click on measure names, and immediately we have a text table with multiple measures. Or we can double click measure values. This will create a bar chart, and from show me menu, I can click on text table, swap rows and column. So we got the same text table with multiple measures. And as we look closely, we will see this count, the default aggregation method is sum. This count is a percentage. It will make more sense if it's average aggregation. We will change it to average, and immediately we will see number 0. That's because the number is not formatted properly. From data pane, select discount and go to default properties, number format. We will choose percentage. And now it looks correct, 15.62%. Similarly, like profit, sales, and discount amount, they are dollars. So we will change the number format to currency standard. So we will name this multiple measures text table. If we look closely to the multiple measures text table we just created, we notice the count of orders is actually not the total number of orders. It's the count of the rows in the orders sheet. That's 9994 rows of data. So we will remove this count of orders because that's not the information we want to see. What if I really want to see the total number of orders? From the original data source, it does not contain this field that can intuitively tell me the total number of orders. But based on the existing field, like order ID, I can create a calculated field to calculate the total number of orders. A calculated field is essentially a new field or column in your data source. And the values or members of that field, of that calculated field, will be controlled by the calculation you use. And this calculation will be done in the data source level. You can right-click over any blank area inside data pane and choose create calculated field. Or you can go to this drop-down menu and go to create calculated field. Let's name it count of orders. And this is the calculation editor. If you click on this arrow, you can refer to the functions available. So I'm going to use count distinct order ID. So this calculation is valid. I'll click OK. So now we see there's a count of orders, this measure field. There's an equal sign in front of it. So that indicates this is a calculated field. Now if I drag this to measure values, and now we see the count of orders is 5009 is less than 9994, which is the count of data rows. And this is really the count of orders. When we create a calculated field, we need to use calculations. In Tableau, there are 4 basic components to calculations. They are functions, fields, operators, and literal expressions. Functions are like sum, average statements used to transform the values or members in the field. Fields are like dimensions or measures from your data source. Operators like greater than or division. Literal expressions like words or number. We'll create another calculated field called profit ratio. We will use function sum, and we will use field profit. We'll use division operator and sum again, field sales. And this calculation is valid. So we'll click OK. And we know profit ratio is a percentage. So we are going to change number format to percentage. And if we add it to measure values card, and then we'll see this profit ratio. On your handout, go to page 21. Create a calculated field, profit per order, and also create a calculated field, profit per customer, and build an executive overview to make it something looks like this. There's another type of calculation. It's called table calculation. Let's look at an example. Create a new worksheet. Drag profit to columns, order date to rows, product category to rows, and we got this bar chart. If we drag profit and drop it next to the first profit in columns, then we got a side-by-side bar chart. If we turn on the mark label, then we can see profit has been aggregated by year by product category. What if for the second bar chart, I want to see the percentage instead of the total amount? There's a built-in feature for Tableau. From this drop-down menu, you can click on Quick Table Calculation and go to percent of total. And immediately you will see the number has been changed to percentage. You will see a delta sign for the profit, the second profit pill. So that indicates there's a table calculation applied. Click on Analytics and drag totals and drop it to subtotals. So now for each year, we have a subtotal added to the view. So the percentage is a percentage across all 4 years. What if I want to see percentage for each year? We can change the scope of the calculation. Click on the second profit pill from the drop-down menu, go to Compute using Pane down. So by default, the scope of calculation is table down. So we can change it to pane down, and immediately we will see the calculation is based on each pane. Over here is each year. Back to data pane, drag category to filters and just click OK. Click show filter. So if I uncheck furniture, and you will see the percentage has been changed. If I check furniture, and the percentage is changed again. So that means this table calculation is based on the data in the view. So when data is added or removed from the view, the calculation result will be changed. So this is different than the calculation that is done in the data source. Say this calculated field, profit per customer, this is done in data source. We have created a calculated field, a new field or a column that is added to the data source. And the calculation is done in data source row level. So this will not be affected by the data in the view. So if I remove this profit per order, the profit per customer, this calculation will not be affected by whether profit per order is in the view or is not in the view. So if I add profit per order back in, we see profit per customer is not affected. Regular calculation is done in data source. It will not be affected by data in the view. In contrast, table calculation is done based on the data in the view. So if data is added or removed, the calculation results will be changed. We can rename this sheet as table calculation. On your handout, go to page 24. Show the total sales by year and a running total over years. Create a due exit chart. And so when you finish, you should have something look like this screenshot. If your data contains geographic data such as state, zip code, you can plot it on the map to visualize it. For this sample superstore data, we can see city, country, region, state, postal code are all geographic data. Let's see how we can plot it on a map. Create a new worksheet. Bring state to the view area. And immediately we can see 49 marks, 49 states have been plotted on the US map. Back to the data source interface. So when data is connected, each column header is viewed as a field. Each field is assigned a data type. For this one, state is string. It also assigned a data row of dimension or measure. For this one is dimension. In addition, if geographic data is detected, it will be assigned a geographic row for this field. So you will see the globe icon. So if I click it, you will see geographic row, state and province is checked. When a field is assigned to have a geographic row, each value in this field will be associated with a latitude and longitude value. That's how Tableau knows where to plot your locations on the map. And that's why when you bring the state to the view area, a map is automatically generated. We can color this map with like profit, drag profit to color, and we can edit color, say we will use orange, blue diverging, and we will use two-step colors to indicate profit losing state and profitable state. So now we can easily spot which state is profitable and which state is profit losing state. Rename it as mapping data. On your handout, go to page 26. Build a view to show the average time to ship by state on a map. And this is the function you need to use to calculate the average time to ship. And then you can use this calculated field to color the map. When you finish, your map should look something like this screenshot. Parameters are dynamic values that can replace constant values in calculations, filters, and reference lines. Parameters can add more interactivity to your visualizations. Next, we will see how we can create parameters and how we can use the created parameters. Create a new sheet. You can right-click over anywhere inside data pane and go to create parameter, or you can click on this drop-down menu and go to create parameter. We will create a parameter called top n. We'll define the data type as integer, and we will define the allowable values as a range. So minimum is 1 and maximum is 30. I'll click OK, and you will see the parameter will show up at the lower left corner below measures. So parameters are useless until you use it in a calculation or filter or a reference line. So we will create a basic view, say drag profit to rows, customer name to columns. We'll just add all members, and then we'll swap rows and columns sorted in descending order. And I will drag a customer name to filters. And in this filter, I'm going to use the parameter I just created. Click on top by field, top. I will choose the parameter top n I just created. And everything else looks good. I'll just click OK. Click on the top n parameter drop-down menu and click on Show Parameter. Now I can slide the slider to show the top n customers by profit. We will rename this top n customers by profit. On your handout, go to page 31. So this activity is to show top N products by profit and the running total on the same view. So this activity will use the top N parameter in the filter, and at the same time, it will let you practice how to use quick table calculation like a running total. When you finish, your view should look something like this screenshot. The next activity is to create a view to show quantity for each product name. Sort the view in descending order. Use a parameter and a calculated field to split the view into two color groups. This activity will use the created parameter in the calculated field. The previous activity will use the created parameter in the filter. So your finished view will look like this screenshot. In Tableau, under Analytics pane, you can add analytics objects into the view. In the previous activities, we have seen how to add a trend line and totals to the view. Now we will see how to add a reference line to the view. Back to the data pane, create a worksheet. We will build a basic view, drag profit to rows, product category to columns, and segments to columns. We have this basic bar chart. Click on Analytics tab. Drag reference line to the view. When I drag a reference line to the view, Tableau shows the possible destinations for this analytic object. This range of choices varies depending on the type of the analytic object and the current view. So we will drop it to table, and you will see the edit reference line band or box. This window pops up. You can change the scope of the reference line, say per pane or per cell, or we'll leave it as entire table. You can also change the value of the reference line. You can change the aggregation of the reference line. You can format the line to the way you like, and just click OK and rename the sheet as reference line. We are going to create two dashboards. One is executive overview and the other is top N customers by profit. Before we start building our dashboard, I want to go back to the due exit chart. I want to change the order date to continuous months, and I want to edit the color so that the profit will be orange. Okay, now create a new dashboard. I want to use a fixed size, so I will choose 1024 by 768. We see all the worksheets we have created so far. I'm going to drag and drop executive overview, this text table, to the dashboard. And next, I'm going to drop the map below it and the due exit chart and the profit by product category and this scatter plot. Change the size of the text table to make room for other chart. Close all the legend to make more room for the dashboard. I'm going to show dashboard title. I'm going to name this dashboard Executive Overview Sample Superstore. For this text table, I'm going to hide title. I want to change the look of the dashboard title. So click on that. I'll go to Layout. Going to make this interface smaller so that I can see the right colors. Go to background, more colors. I want to use the color picker, the eyedropper, to pick up the rice blue as the background color. So immediately you will see this dashboard title has this dark rice blue as the background color. And I'm going to change the text color. I want to scroll up. So go to more colors, eyedropper, this light gray, and click OK. Okay, so that's much better. If I want to have an information bar at the bottom, I can drag text and drop it to the bottom. Say for questions, make the text rice gray and make the background rice dark blue, and just close it to make it smaller. Now we have this kind of like executive overview dashboard. Now duplicate this dashboard, and we will remove this, all the worksheet. Just leave the dashboard title and the bottom information bar. So we're going to drag top in customers by profit and scatter plot by customer name. And we really want this parameter to control both charts on the dashboard. But right now, you see this parameter only controls the top chart. So what we need to do, go to this worksheet and create a filter that use the top in parameter in the filter. Now back to this dashboard, and you see the parameter controls both worksheets on the dashboard. And we can rename this top N customers by profit. Just click OK. So we have our second dashboard. So in the introduction workshop, we talk about to use filters to add interactivity to your dashboard. And in this intermediate workshop, we talk about how to use parameter to add interactivity to your dashboard.
That's the end of the workshop. Have fun learning Tableau.